15th, which is going to be a talk online, actually, by Slobodan Perovic.
Oh.
You can find the Zoom for his talk, as well as the information about how to access his talk on the website. If you plan to apply for people online, if you plan to apply for the postdoctoral position and the visiting fellowship position at the center, the deadline is on the 10th, so it's actually very soon. You should send your application. Today, it's my great pleasure to introduce someone who does not need an introduction anymore, because it's the fourth time or fifth time in like 2 years I'm introducing him, Arnon Levy, who is currently the senior visiting fellow at the center. He's been with us for 2 years. Last year he was a fellow, and this year he's our senior visiting fellow. We've been very lucky to have him for now 18 months and 6 more months to go. He's professor at the Hebrew University of Jerusalem. He got his PhD from Harvard now a few years ago. Works in the philosophy of biology as well as the philosophy of science. He's done a lot of work on mechanistic explanation, on models. He has edited a book with PGS, I believe, on imagination in science with OUP, and he's finishing a book which I've read nearly all of it on explanation, which should be out maybe next year, or hopefully, yeah, with Routledge, right? And which I can highly recommend. An important survey of the literature on explanation. And today, he's also organizing, as a senior visiting fellow, a conference on science and value, which will be taking place in April. It's on the website if you're interested. And today we're going to have some insight about some of his thoughts on the matter, with a talk titled "A Critique of the Argument from Inductive Risk." Arnon, the floor is yours.
Thank you very much, Edouard. Thank you all for coming. I know it's the end of the semester. It's like the last few. So yeah, thanks for making it. Some of you, as Edouard mentioned, I was here last spring. Some of you saw me talk about inductive risk last spring. That today's talk is a kind of descendant to that talk. Back then, I tried both to critique this idea of the argument for inductive risk and to suggest a kind of sketch an alternative. And I've come to think that the critique has to sort of be sorted out first. I've also made some pretty significant changes to it, although the spirit is quite similar. One thing I think I've sort of become clear on is the kind of starting point, and it's this. There's been a surge of writing on science and values, and it's emphasized to a great extent the social sort of embeddedness of science. And it's seen as important, in particular, from a kind of philosophy of science perspective, to highlight the ways in which science serves society, influences the public, the social good. And most current writers in this area also hold that scientists ought to consider the potential social implications of their work as part of their ongoing research activities. And in fact, I think it's common to take the former idea to motivate the latter. So the thought is, because science should enhance and promote the social good, scientists should consider social implications of their research. And one central way, and one sort of important argument in this area that fleshes out this connection is the so-called argument from inductive risk. Some people refer to it as the error argument, less common, but also exists. And this argument suggests that because scientific reasoning is error-prone, and because errors carry costly consequences, scientists should factor these consequences into account when they do their research, and they should appeal to values to determine which errors are most important to avoid. So the argument for inductive risk has become a kind of central in basically an assault, you might say, on the so-called value-free ideal, which was once more dominant in philosophical, I think also in scientific circles, and has become far less widely accepted. There's no, I think, canonical formulation of this idea of the value-free ideal, but one version of it holds that, where critics of it sort of say that the working scientists, or I should put it this way, people who affirm the ideal think that working scientists should not appeal to moral, political, social values in the course of their work, where critics of the value-free ideal deny this. So the kind of thing I want to do today is try to sort of turn the tables on this in a sense, and suggest that the underlying concern, the concern to have like a science that serves society well, that advances social ends, should lead us away from assigning social responsibilities to science. And I want to emphasize that this is meant to apply to individual working scientists, because I'll explain, the view does, I think, leave room for values to structure institutional norms to guide decisions in other science-related bodies like scientific advisory committees, stuff like that. I'll mention specifically scientific advisory committees near the end. And more generally, I think that discussions of the role of values in science are not sufficiently attentive to distinctions between units and levels of analysis. So in a sense, if I'm only able to sort of sharpen that question and put it on the table, like which unit are we talking about? What role of scientists are we talking about? I think that's also kind of valuable contribution. So I frame the topic in terms of values and value freedom. I think that's both a well-known way of framing the issues and also in some ways a helpful way of framing device. But for the remainder of the talk, I'll mostly, except towards the end, I think, avoid talk of sort of values and value judgments. I'm not in principle opposed to this notion. As I said, it's a good framing device, but it's also true that the terms value and value judgment get used in a multitude of ways and sometimes in a confusing kind of confusing fashion. Some people think there are both epistemic and non-epistemic values. Other people disagree. People sort of are unclear about whether values are motivating a decision or justifying it. Zena Ward has written about that in a helpful way. I don't think that I need to take a stand, and I don't want to, and I hope I don't need to take a stand on these questions about what values are and how they enter. And so I'll mainly talk in terms of considerations. So the question would sort of be whether and how scientists should appeal to moral, political, ethical considerations in the course of their work, and especially when they should take social consequences as considerations into account. So here's the basic plan. The first thing I'll do is kind of present the argument from inductive risk, state it, emphasizing how it applies at the individual level. Then I'll try to show that the argument, which might seem in a sense modest, actually places a pretty significant kind of burden on individual scientists, one that amounts to both framing socially relevant decisions and assessing their consequences in a kind of full sense. And against that background, I'll try to make 2 or 3, that depends exactly how you count, arguments or sketch some arguments that say that individual scientists are not well placed nor well equipped to carry this kind of burden. And furthermore, that if you think that both scientists as individuals and sort of other organs of society are to make these kinds of decisions, then you get into problems of like skewed decision making and accounting, stuff like that. And then sort of at the very end, hopefully I'll have time, I'll just make a quick few comments about like where this leaves us and what sort of somewhat more general lessons we can conclude from this. Okay, so what is now usually called the argument from inductive risk dates back to the work of several authors from the 1940s and early 50s, maybe best known as Richard Grundner. And more recently in the sort of 21st century, it's been sort of brought back into the philosophy of science discussion, especially by Heather Douglas. It's also been kind of strengthened and elaborated in that context by Douglas. And the starting point for this argument is the idea that scientific reasoning is error-prone. And more specifically, the observation is that in the course of an investigation, a scientist is at least implicitly balancing the chances of making some errors relative to others. The most sort of crisp way to see this is in the context of statistical hypothesis evaluation. So suppose you have a scientist that is considering whether a data set allows them to reject a null, a null hypothesis. So formally speaking, they're asking whether the data's p-value is below a threshold alpha, which is the significance threshold. And the higher that threshold is, the sort of easier it is to reject the null, and so the more likely a false positive becomes, or conversely, false negatives become less likely. So by working, the thought is by working with a particular alpha, the threshold, the scientist, in effect, is balancing the chances of making some errors relative to others. And the point is not meant to be confined to statistical testing by any means. The thought is like much more generally in any empirical investigation, there's a risk of erring or making a mistake in one direction relative to the other. And so deciding that the evidence licenses a claim is deciding to prioritize some errors over others. Now, the question is, how do you balance those errors? How do you do this prioritizing? And what both Rudner and in much more detail Douglas later on suggest is that scientific decisions often have practical consequences, practical implications, and they argue that this should set the error threshold. So Rudner considers a hypothesis about drug safety. He says, given a data set, to accept that a certain drug is safe would require, as he puts it, a relatively high degree of confirmation or confidence. So the consequences of making a mistake here are exceedingly grave by our moral standards. On the other hand, if, say, our hypothesis stated that on the basis of a sample, a certain lot of machine-stamped belt buckles was not defective, then the degree of confidence we would require would be relatively not so high. And then sort of a bold, italicized sort of conclusion here is how sure we need to be before we accept the hypothesis will depend on how serious a mistake would be. So overall, the argument is, since the scientist risks errors in deciding whether to accept or reject the hypothesis, since errors have morally significant consequences, the decision whether to accept the hypothesis should take those consequences into account. Specifically, it should affect this judgment of how strong the evidence needs to be for the hypothesis to be accepted or licensed. So before I just get into any kind of discussion, I want to sort of highlight a few things, make a few comments. First of all, I presented the conclusion, as I emphasized, in terms of the roles of scientists as kind of agents of scientific decision-making. Sometimes you see the argument being made in a kind of more abstract or different way. I'm not really sure whether an argument that doesn't sort of point to the person making the decision really gets off the ground in the same way, but I'm going to just set that aside. I'm going to focus on this version of the argument, which I think both Rudner and Douglas and a bunch of others really have in mind. Rudner is fairly clear about this, and Douglas is, I think, even clearer, because part of our argument, which I'll get to later, appeals to the moral duties of individuals, of scientists as individuals, which include what she thinks are duties to avoid negligence and reckless conduct. So she clearly sort of has the individual scientist as a sort of moral agent in mind, and I think Rudner as well, and several others. That's the version I'll focus. The second point is maybe not, maybe we don't have to sort of go through this in detail, but the argument might seem modest. It might seem like it sort of just assigns a kind of modulating role to moral considerations. But really, first of all, that modulating role amounts to more than just kind of threshold setting. I'll talk about this a little bit later, some more, but Douglas and others have suggested that consequences should enter into scientific consideration at other points in the scientific process. So it's not just this kind of modulating kind of error setting role. It's also the case that consequences in principle can overwhelm evidential considerations, even if you just focus on a modulating role. If the stakes are high enough, basically evidence kind of gets overwhelmed by mistakes. So it's not a modus argument in that sense. The third sort of preliminary point is that I've put this argument in kind of strictly normative terms. It's an argument about what scientists ought to do and which considerations they should appeal to or incorporate. Sometimes the argument is presented with a kind of more descriptive flavor, where the idea is that scientists in fact take consequences into account, or they somehow have to take consequences into account. I'm not sure how that version of the argument works. I'm not sure what exactly is sort of the reason for thinking that this in fact or necessarily has to be the case, and how you get from that to a kind of normative conclusion. But I'm going to just set that aside, just focus on these versions of the argument which say consequences matter, and therefore the scientists should appeal to them to make these kinds of decisions. So it's the sort of clearly normative version that I'm going to focus on. Okay, so we have an argument that says that scientists should take consequences into account, of error into account, at potentially many stages of the scientific inquiry, and in a way that sort of potentially overshadows evidential considerations. The question is what to make of it. I think there's a kind of important insight here, but I don't think we should accept the bottom line. But before I sort of get to why I think that, I want to sort of look at two insightful, I think, but ultimately I'll say unsuccessful responses. And the reason I mentioned these two responses is because there are elements of them which I kind of want to incorporate, but there are a bunch of other responses. I don't mean to survey responses here. I just want to sort of highlight two sort of points. One line of response is that insofar as someone is a scientist, they should focus on epistemic considerations and set aside moral, practical upshots. There are different ways of developing this sort of basic idea, this sort of insofar as someone is a scientist idea. But Sandy Mitchell has one version of this in a paper from 2004, where she distinguishes the role of the scientist from that of the policy advisor, and argues that only in the sort of advisor capacity should these moral, social, ethical considerations really enter the picture. Of course, she accepts that one and the same person can be both a scientist and an advisor, and she sort of discusses the fact that could lead to kind of complicated negotiation of these role obligations, but she thinks that we need to distinguish. It's only sort of the right way to frame stuff is to sort of distinguish these roles, talk about these different sort of obligations that attend to these roles. So that's kind of the basic idea. And I think that the idea of a role and role obligations is an important one. And in a sense, what I'm going to argue is a claim about roles and role obligations, a role sort of what goes along with the role of the scientist. But I worry that the argument, as Sandy makes it, starts from assumptions of that sort. It starts from assumptions about roles. And I think we can't help ourselves to that kind of assumption. We need to derive, as it were, role obligations from some other principle, independent or more basic or whatever you want to call it. It's partly because I think it's just unclear, when you come to this discussion, what exactly is involved in the role of the scientist and what isn't. It's not an obvious question. It's also dialectically, Rudner and Douglas, I think, are very clearly putting forward a claim about the role obligations of the scientist, right? Rudner's title is "The Scientist qua Scientist makes value judgments." So in this context, there is a kind of danger of begging the question, right? They say the role is this, other people say the role is different. How do we adjudicate that? So that's sort of one thing which I kind of think I want to take on board, but in a different way, trying to sort of argue for the role claims based on other considerations. The other maybe best known response to the inductive risk argument goes back to Richard Jeffrey in a paper from fairly short while after Runyon published his paper. And Jeffrey basically challenges the apparent underlying picture of hypothesis evaluation that Rudner had in mind, which kind of treats it as a binary decision, accept or reject. And some people, Jeffrey and a bunch of others along the years, have seen this as a pretty crucial mistake in this context. They think the argument can be basically avoided, circumvented, if we don't take hypothesis to evaluation to result in a kind of yes or no on-off verdict, and instead opt for something like a probability or some other graded notion. This kind of probability, the thought is, then feeds into decision making alongside value judgments in some systematic way. Jeffrey appealed here to versions of utility maximization, but that's not essential, I think, to the response here. The essential aspect is scientists apply probabilities to decision makers, which then incorporate value considerations. Now, I'm a little bit sort of torn about this response, I have to say. I think, and I hope this will become clear, that it's correct to frame matters in terms of the contribution of science to sort of social decision making, and not merely in terms of sort of urging scientists to factor in consequences. I'm also, just on separate grounds, sympathetic to the idea that hypothesis evaluation is conducted in something like probabilities or some graded notion, and that often the on-off thing is not, at least not the sole way to frame hypothesis evaluation. But that said, I think that in scientific context, there's also important room for sort of outright affirmations and denials of claims. So I'm not I think there's, especially in policy-related context, that often is important to just sort of lay down a claim, say yes or no, this will happen, this is what science says, yes or no. But there's a bigger problem, I think, whatever you make of all that, there's a bigger problem with the Jeffrey response, which is that it can't be the full story. And that's because you can extend the inductive risk argument beyond hypothesis evaluation. And here I think it's a very sort of important move that Heather Douglas makes in a bunch of places. She gives different examples, but the best known one is research on dioxins. Those are human carcinogens that also have industrial uses. And she points out that, research on dioxins, you basically take the chemical, you expose rats to it, then you look at rat livers, and you see, what proportion are these rats getting the relevant kind of tumors. As she points out, this is a kind of ambiguous matter. You can, in some cases, the samples are, requires judgment whether they should be put in one sort of bin or the other. Do they have a tumor or not? And she thinks, well, here we have the sort of inductive risk issue all over again. If you decide to err on the side of caution by counting in the ambiguous sample, then you get the risk from dioxin will turn out to be higher. If you err on the other side, the risk will be assessed to be lower. And this is just, I think, I think duly give Douglas credit for pointing this out and making everyone see that this is a big deal. But there's a bunch of other authors who have pointed out that something similar happens you can find it in experimental design and model construction. So the point is, there are a lot of other aspects of the scientific process where these kinds of considerations can enter. So even if you just accept the Jeffrey line about hypothesis evaluation, I think it doesn't suffice to sort of overcome the basic thrust of the inductive risk argument. There's a lot of room for kind of discrete on-off-ish decisions in science where you can't just work with a probability in the way that Jeffrey suggested. Okay, so summarizing these sort of two responses, I suggested that Sandy gives us the idea of role obligations, which I think that's a good concept to have and to frame matters with, but we should probably not start from those claims about roles. And then Jeffrey claims that scientists' contributions should be conceptualized probabilistically, but I think that sort of probabilistically and as one contribution to social decision making. And I said that while it's sort of good to frame matters in terms of social decision making, the yes/no decisions are important in science in various places within the sort of scientific process. Once we expand beyond hypothesis evaluation. So with all that in mind, let me try to offer a different kind of response to the inductive risk argument as it applies to individuals. The first thing I want to argue is that the inductive risk picture, well, I guess in the bigger picture, what I want to argue is that the inductive risk argument goes wrong in placing a kind of heavy evaluative burden on the shoulders of scientists, individual working scientists. And I think that if we want a science that serves society well, then we should not assign this kind of role to individual working scientists. So the first thing to argue in this context is that the inductive risk picture does really have this sort of implication, right? That it places a substantial sort of evaluative burden on scientists. You might think that's not what Rudner and Douglas are talking about. After all, they talk about what seems like a more limited claim that scientists should concern themselves with errors and the risks of making some errors relative to others. I think they do indeed say this, often emphasize this, but I don't think this is a kind of stable position. Here, I mean, this has sort of been sharpened to me by some work and some discussions I've had with Zina Ward, who has like some work that hopefully will be published, but so far is not published on this. But I want to give her credit for like helping me see this, definitely. But I also want to just say that I don't think she accepts what I'm going to argue follows from this, right? So, but anyway, Zina, following Sarah Moss in some work on discussions of moral encroachment, which we're not going to get into, distinguishes the risks of an hypothesis from its costs. So the risks are negative consequences that follow from error, where the costs are just negative consequences, whether you're right or wrong. No, not specifically attached to error. Now, as the name implies, the argument from inductive risk focuses on risks. It suggests that scientists should consider only consequences that follow from error. But the question is sort of what justifies this restriction? Why should they focus on those consequences and not on other consequences? Douglas, as I mentioned earlier, argues that scientists should avoid negligence and recklessness. And she thinks that that's sort of a crucial point here. So she makes an argument that sort of draws an analogy between a scientist considering an hypothesis and an everyday context in which you come across a briefcase that might contain a bomb, and the question is whether you should report it as a suspected bomb or not. And she says, surely, if the stakes are sufficiently high in the relevant context, you're in a public crowded space, there's some reason to think the bomb threat are imminent, then you should report it, right? And she takes this to mean that she takes this to show that even if you might be wrong, you should report it because the consequences of not reporting it, of getting it wrong, are just too high. So she says we can be negligent or reckless in making descriptive or empirical claims. Then she goes on to say, well, in the same manner, scientists, it's not just a general duty that people have. In the same manner, scientists in their ongoing work have similar responsibilities. I'll get back to the second part later for a reason that will become clear. But first, Douglas sort of speaks as if negligence and recklessness are specifically associated with errors, right? But I don't think that's just, I think, incorrect, right? If I'm been on the bomb squad and I'm good at detecting bombs and I'm in a public crowded space and there's some reason to think that a bomb might be present, then if I decide not to alert anyone, then I'm being negligent or reckless, as the case may be. And it's got nothing to do with whether, I'm likely, suppose I'm not likely, I'm likely to be right. And so I think it would seem that if there's a duty to avoid negligence and recklessness in the case of potential errors, there's also this, it's just irrespective of that, it has to do with the consequences and not so much with recklessness or negligence. So by the same token, if scientists in their work, in their ongoing work, are similar to an ordinary person facing a suspected briefcase, then they should consider all costs and not just the costs of error. I think something similar can be said about what Rudner, it doesn't quite make an argument so much as a kind of maybe a motivating comment. It also extends pretty directly, I think, pretty readily from risks to costs. So Rudner thinks we should adopt a higher evidential threshold when deciding about whether a drug is safe or not, because as he puts it, the consequences of making a mistake here are exceedingly grave by our moral standards. I quoted before. But it's just very hard to see why the graveness of the seriousness of the mistakes should matter only if the drug is unsafe and not if the drug is safe, only for an error about this relative to whether we're wrong about this. Clearly, Rudner has in mind a situation where declaring an unsafe drug safe is a very bad outcome, but that's just something about the balance of consequences. It's not a claim about, when you think about it, it's not a claim about whether you're the gravity of this consequences is just a matter of like, he thinks like, usually the risk of distributing an unsafe drug is more serious. It's not about whether the scientist is right or wrong. So I think overall, and kind of similar to what Dina Ward suggests, the Rudner-Douglas line, I think, implies that scientists should take account of costs and not simply risks, the risks of error. Now, a second question sort of comes up, and that's like, well, if costs, why not benefits? Right? This is something that Zeno doesn't explicitly consider, I think, but is very natural extension of what she says. Douglas's briefcase example, I think, pretty readily also extends to cost. If the briefcase, contains some information that will help defuse a bomb or save lives, then I would be as negligent or reckless in not reporting this in the relevant circumstances. So it's not just about costs; it's also potentially about benefits. I think something similar can be said about the Rudner line, when there are benefits to distributing the drug, and that those are taken into consideration. It's not just a question of the cost; it's a balance of costs and benefits. So I think the analogy now a comment here, which I've heard discussed this before, is well, but costs are relevant because they matter to whether someone should sort of act or not, and there may be a limit to the sort of costs that sort of moral duty can impose on the person. This is sometimes called the demandingness objection in various ethical contexts. So if you have that thought in mind, I don't think this is a relevant sort of issue, right? Demandingness has to do with the costs on a person acting, to save a life, to do something, to give money to charity. Here we're talking about a scientist and a kind of third personal perspective weighing costs and benefits to society. So demandingness, some people have sort of mentioned this kind of objection to me, but I don't think really it enters the picture. It's not the right way. I mean, that's just a kind of aside if that's a point to you. Okay, so here's a kind of interim conclusion. I think the motivation for the inductive risk argument extends from risks to costs as well as to benefits. If you hold that scientists should factor in the consequences of error when evaluating hypotheses and other aspects of science, then you should hold that they should consider the full range of consequences. Now, this might already sound to you like a kind of task that scientists should not or will not do a good job with. And that's something I'll argue in a minute. But first, I want to kind of amplify this kind of full range of consequences thought with another point, which appears originally in Jeffrey's response to Rudner, but is often kind of either misunderstood or downplayed in a way that I don't fully understand. So I want to kind of clarify it. So Rudner and Jeffrey wrote the original stuff in the 1950s, mid-1950s, and this is a time where the polio epidemic, that's a polio virus, it's not COVID, kind of similar, but not. So the polio epidemic was like raging at the time. 1955 is when the Jonas Salk inactivated virus vaccine came out. And during the initial rollout, it was, this is not mentioned in Jeffrey, but this is a kind of background to an example that he gives. During the initial rollout, there were some batches that were included active viruses and ended up causing the disease instead of like vaccinating people against it. So in this kind of context, Jeffrey considers a scientist trying to decide whether a given batch of vaccine is virus-free. And he says, well, look, if the inductive risk argument is right, then this is a clear case in which the scientist should appeal to consequences and on that basis decide about the hypothesis. But then he says, look, there's nothing in the hypothesis this vaccine is free from active poliovirus to tell us what the vaccine is for or what would happen if the statement were accepted and false. One naturally assumes that the vaccine is intended for inoculating children, but for all we know from the hypothesis, it might be intended for inoculating pet monkeys. One's confidence in the hypothesis might well be high enough to warrant inoculation of monkeys, but not of children. The basic point here, and it might not be best conveyed with this example, although it is kind of, he puts it in a good way, but the basic point is that it's often, as I said, often kind of either ignored or sort of misrepresented, is that accepting or rejecting a scientific hypothesis can't be equated with accepting or rejecting any particular action, because there's just no direct mapping between hypotheses and actions. One and the same hypothesis can form the basis for different actions with very different consequences. And so, you know, assessing the costs and benefits associated with a piece of science depends on which actions are at issue, what other alternative courses of action are available, what affected parties there are, and so on. And as I said, I mean, maybe this is not the best sort of context or way in which to make this point, although I think it is kind of interesting that it can even be made with respect to a very sort of action-related hypothesis like this one about vaccine, a batch of vaccine being sort of virus-free. And just consider like atomic fission or CRISPR-Cas gene editing or discoveries about, you know, room temperature superconductivity. Just the thought that there is sort of consequences attached to any specific scientific hypothesis in these kinds of questions, in these kinds of matters, I think sort of greatly and incorrectly oversimplifies the kinds of mappings between the science and the relevant actions. So another way of putting this is to say there's just sort of, there's no, you can't follow the science. That doesn't really mean anything, right? You first have to sort of consider an action and then decide which pieces of scientific sort of information are relevant to it and happen. Okay, so the earlier thing I said was that the argument for inductive risk implies that scientists should consider the sort of full range of costs and benefits associated. You can't just focus on errors. And I think this point from Jeffrey kind of compounds this. Consequences don't attach to an hypothesis per se, but to actions. And so the facts of the case, which scientists are sort of considering, will usually be relevant, but the consequences and how to evaluate them are consequences of action or policy. And they vary on a kind of action by action, policy by policy basis. So in effect, the scientist is not only required to consider a full range of consequences, they're in effect already sort of implicitly supposed to sort of frame which action are on the table. And only then can you sort of even talk about assessing consequences. All right, so in effect, what I've tried to sort of so far say is that the task that the inductive risk line assigns to scientists kind of has the order or the complexity of social decision making. It requires them to sort of conceive of the social decisions on the table, the policy options on the table, and then to kind of assess costs and benefits. It's not, you can't just stop at sort of assessing risks in the simple way that Runner does present. And that might already seem to you like, okay, maybe we've assigned this kind of task to the wrong actor in the system. And I think just bringing that out already sort of at least suggests that thought. But I also think you could make several arguments, more explicit arguments for this claim. So the first argument is that I'm going to sort of just sketch these arguments. I think each one of them can and should be further developed, but I want to kind of try to sketch all three of them and arrive at a kind of more comprehensive case. The first, I think, is that scientists are just not well equipped to carry this task, right? So in any kind of conception of this sort of social decision making, you need to have a good sense of social realities, what possible policies are available, what kind of social policies are feasible in terms of like whether the government can execute them, whether the public will comply with them, what the opinions of various parts of society will be on them. We've seen this very clearly in recent terms, in the COVID crisis in a very clear way. Question of like which policies are like feasible, what kind of level of compliance we'll get, what alternative courses of actions they are. Those are very complicated questions in their own right, and they require usually specialized sort of skills, specialized information bases. They're not the kinds of things that individual natural scientists for sure ordinarily work with, and the kinds of skills that they have. It's also arguable that scientists are not very good at assessing consequences, right? That requires an understanding of how to evaluate costs and benefits to different parts of society, to different groups within society, what these groups of society value, material gains, status, various freedoms, weighing and balancing these kinds of things. Again, not, I think, arguably within the proper skill set of a scientist and the kind of training that they have. So they're not the sort of calculations that scientists are. I'm not saying they shouldn't be assigned. I'm saying they're not going to do a good job with these kinds of calculations. That's kind of first sketch of an argument. Second sketch of an argument has to do with incentives. So scientists' career and career prospects, usually their reputation to a large extent depend on their ability to make interesting, productive, novel claims. That's what gets them, promoted and funded, and that's what secures a reputation for them and stuff like that. And even sort of more importantly, having the proper incentive structure in that sense within science is required for us to get like a good science, right? To get like good scientific outcomes, which in the end sort of contribute to science's ability to inform policy, to develop fruits or to bear fruits for society. But I think there's a kind of misalignment between this kind of incentive structure and the incentive structure that confronts someone deciding on which science we should act on in a policy context, right? And this is a key insight of the inductive risk argument. In a policy context, we often want to take errors and be cautious in various ways, in ways that your sort of everyday scientists, it's not only that they aren't sort of inclined to do, they probably shouldn't be inclined to do, because that's not a good way for science to operate in general. So I think another way to put it is sort of policy should not be grounded in sort of the most interesting, novel, new cutting edge science. It should be grounded in the science that sort of serves the goals of policy most directly. So I think that both in terms of the sort of skill set and in terms of the knowledge base, and in view of considerations having to do with the right incentive structure, individual scientists, working research scientists are not people to do this kind of work. Right. Wondering if I should, yeah, I'll just make a brief comment about something that Heather Douglas says in this context. At one point in her 2009 book, she considers this idea, whether it's sort of, I don't think she puts it entirely in this term, but sort of whether it's the scientist that should be doing this thing, whether it's sort of fair to place this burden on scientists, whether it's part of the role of the scientist. And one main thing she says in response is, well, while the science is being done, presumably only the scientists can fully appreciate the potential implications of their work and the potential errors and uncertainties in it. And I want to sort of say about this that there's definitely something to this, right? In many contexts, it's going to be the case that only scientists who understand the work can evaluate, like, or see certain consequences that might not be obvious at all to other people. But what I've argued doesn't conflict with this. What I've argued is that scientists shouldn't sort of do this as part of their research work. It doesn't mean that they then can't serve on advisory committees. It doesn't mean that they can't flag interesting and important and maybe consequential, risky upshots of their work to policymakers, to advisors. This claim can be accepted while also not thinking of scientists as having to sort of incorporate the consequences into their ongoing work. So I think Douglas is making a good point here, but a point that doesn't really, I think, we can take on board and still deny her sort of key conclusion. Okay, a third and final argument that I want to sort of make, which is sort of separate and apart from the claim about scientists being not well equipped and not in the right incentive structure, is that kind of a double, I think of it as kind of double counting argument on word. And the starting point of this argument is basically that policy relevant decisions will necessarily and centrally involve actors other than individual scientists. And I think no one does and should deny this. The main burden of sort of deciding on policy lies with political representatives, policy professionals, various bureaucrats. It depends on the exact context. And I think advocates of the inductive risk line don't deny this. But if we think that, there's a kind of danger of sort of double counting and bias if we also think that scientists should take consequences into account, right? And maybe even worse, the sort of action possibilities that the scientists consider might not sort of align with the action possibilities that then actually are relevant when policies really decided on by, politicians, by policymakers. And I think it's easy to see that, if you take the sort of Rudner-Douglas type of decisions, the examples they give, you decide on a certain chemicals like safety, and suppose the scientist is sort of errs on the side of caution, but then the policymaker also decides to err on the side of caution. Clearly, what might happen here is that, we err too much on the side of caution, right, in this kind of situation, and that's by definition a bad thing. That's why we err too much on the side of caution. So the thought, I think an even worse situation is whether, a scientist assumes that, a drug is used in one way, but it gets used in a different way. What we get in this kind of situation is a kind of bias and skew in the way in which costs are factored into policy. There's like too much factoring in of consequences potentially, or the wrong factoring. Okay. Some conclusions. I'll skip these clarifications. I will come back to them. that question. So there are basically two parts to the overall argument. The first is that advocates of the inductive risk view underplay the implications of their argument. If we think that scientists should consider consequences of error, then we should think that they essentially have to both frame decisions and assess consequences in a comprehensive way, not just risks, but also costs, not just costs, but also benefits. And secondly, I argued that scientists are not the right actors. The role of the scientists should not really include this because they don't have the relevant skills, they don't operate under the right incentives, and having scientists do this task would result in a kind of double counting and potential skewing of decisions if the task is also, as it probably should, be performed by other actors in the sort of socio-scientific system. Now, critics of value freedom, the value-free ideal, often present that ideal as amounting to a kind of claim that science should be, as Heather Douglas puts it at one point, insulated and isolated from broader political and social or societal concerns. And it's possible that some presentations of that ideal do have this character. I don't want to necessarily deny that. But what I've tried to sort of argue for is a kind of almost an opposite claim, right? It's the claim that if we want science that is sort of well suited to serve society, that really contributes in the right way to sort of social ends and goods, then individual working scientists should not be assigned with the kind of tasks that the inductive risk argument assigns them. You have to assume the picture, not just the argument per se. So the argument is sort of, or the discussion is emphasized considerations having to do with how science serves society on the one hand, but also questions about sort of, as I put it in the beginning, what kind of unit or level is the right unit or level at which to sort of think about this stuff. So here, sort of in closing, we might kind of come back to Mitchell's this sort of distinction between the scientists as scientists and as a policy advisor. I think that considerations of science's sort of service role or sort of role to help society would play out quite differently if we consider scientists acting as policy advisors. And I'm not going to get into this, but I think speaking generally, science advice is, by definition, a kind of means and activity, right? So policy benefits when science is sort of tailored and framed relative to specific ends, and that has important implications for the role of the science advisor, which I think doesn't follow the kinds of considerations that I mentioned here today, and does maybe comport much better with the inductive risk line. Now, I'm not saying this in order to sort of establish any kind of claim about policy advice, and I think that's a complicated question in and of itself. I'm just trying to sort of highlight that the issues look different when you take into consideration both sort of how does science contribute to society overall, and which actor in the overall system are we talking about, and what is their role relative to other roles, given this sort of desire to have science serve society well, contribute to social ends, which I think to be a kind of motivating thought behind this entire, a lot of this sort of literature and inductive risk and science and values. Thank you.
We'll take a quick break and then we'll have plenty of time for questions.